Hey everyone, thanks for joining today. I'm not sure where you're joining from, but do let me know if you are joining us from somewhere on Earth. I am just finishing the setup of the stream and I should be ready to go. Do let me know if the music is too loud. I hear it at a different volume than you do. I look forward to investigating a little bit more about the road accidents in Switzerland that we actually were covering in this stream last year. I can say last year now because we started 2021 already. So welcome to the new year. Welcome to my stream today. I'm looking forward to having some people join, ask some more questions. We had a great stream last time with a lot of curiosity. So I really look forward to anyone who would like to know more about what I'm doing. So as I said, I'll be continuing off from last time where we were actually looking at these road accidents in Switzerland. So we got some data from the Federal Statistical Office. We got some data from Meteo Suisse, which is the weather data center of Switzerland. We also have some information from Swiss Topo, which is the topography, street road data source of Switzerland. So basically Switzerland being measured, literally. And yeah, using some of that data, mostly the data from the Federal Statistical Office, we were actually looking at the number of accidents that occur in Switzerland, and maybe drawing some preliminary conclusions from that. What we did find, however, last time, not to summarize the whole stream, but what we did find is that some of the data can be joined together and some of it cannot, for a couple of different reasons. And so what I wanted to do today was actually cover these three things. So the first thing is, how do we actually calculate the total number of accidents per year? Because we have a lot of data, we have a lot of data from different perspectives, which doesn't necessarily tell us the same thing. So we have to figure out how we want to actually calculate data in the first place. And in this case, it's the total number of accidents per year, because that's our kind of baseline number. And that's what we were looking at last time. The second thing we want to look at, in my opinion, is, okay, how do we determine if we can actually join two different tables of accident data together? And I'll be showing you that directly in my in DataGrip in my IDE in a second. And the third, well, can we find out something interesting? As I said last time, there is a lot of data and information available about accidents in Switzerland already, but I am curious to look at the data myself and see what we can find out. Oompa, welcome back to the stream. This is my job, but also my hobby. I've made my hobby into my job, maybe, if you could say that. So I do this in my free time as well. I do other things in my free time, obviously, besides data analytics, but yeah. So yeah, you could say that I'm, of course, flexing my skills outside of my job to help myself also in my job, but yeah, it's primarily, I would say, my interest and motivation behind it. It's not about getting better at my job, but more just doing something that I enjoy. And you know, I added the educational tag for the stream today because I actually was thinking about it over the new year, and I basically thought, well, one of the reasons I'm doing this on Twitch is to try and educate others and give people like yourself a chance to interact in real time and ask questions. And so it is educational for me. Otherwise, of course, I would just sort of look at it on my own and not stream it to the world, right? So so yeah, I am very interested to see what we can find out. We did find out a couple things last time, but I just wanted to cover cover the last sort of 10 minutes of the previous session, just because it will make a lot more sense. So I think if that's clear, unless there's any questions, we can hop over to DataGrip. So, DataGrip. I really like this program. It's from JetBrains. It allows me to save my queries and all that kind of stuff and access these databases. If you haven't been on a previous stream before, then I'll just run for a minute or two about this setup here about Postgres. So I'm actually running Postgres in a local environment within Docker. The reason I'm doing that is because I can easily sleep the Docker container and just fire it up next time I need it. I don't need to have the database running in the background all the time, as you will. Docker can run other things for me, other projects that I work on. I've been working on a small recipe database, for example, for me and my girlfriend to store all of our recipes in. So that's the reason for using Docker, because it's very convenient. And I actually have a copy as well of an open source BI, so business intelligence visualization tool called Metabase, which also runs within Docker, and they can connect together. So I can use Metabase to visualize something that we find out, which I was doing in the first and second streams on my channel, which unfortunately are not available anymore. But I will be creating a YouTube channel to actually put the full Twitch streams on, because Twitch only retains them for, I think, 7 days. So I'll be linking to that later in my profile. I should have that up and running this week, so that you can watch also all the previous streams, because this is already actually the 5th stream that I've been doing. So yeah. So let's just summarize the finding that we had from last time. So we had these 3 different schemas. This is the Federal Office of Statistics. This is where our accident data is coming from. Also the cantons data with the postcodes. We had the MedioSwiss data, which we hadn't gotten into yet. I just spoke about it, that I had I had downloaded some weather data for the past 200 years. Whether that's interesting or not, we'll find out. And I had also downloaded street information, which is very interesting, actually. Basically, every single street in the country is also here with a easting and northing point. So it's not actually the whole street mapped out, but it's sort of the midpoint of the street, if you will. And I actually went and converted these to lat/lon in case we decided that we were going to use this data in some way. But we hadn't done that. Oompa, thanks for joining. Oompa Loomper. Go read your book. I hope it's interesting. And maybe we'll see you again soon. So, the street data is pretty interesting, but I don't think that we're going to be using it right now. One of the things that we were looking at last time was the sums of the accidents. So if we go back all the way to the first query that we designed, this was the one here. So we made like a yearly summary of the accidents per canton. So these were kind of like the, if you can see this. If you can't see it, if it's too small, just let me know. So we were seeing all the yearly accident numbers from this road accident canton table. And actually, if you see here, basically there's sort of all the classifications of how many accidents there were based on the severity of the accident. So this Unfallschwere, I apologize for some of the data being in German, by the way. It's unavoidable. I'm not able to translate everything. But when we run the analysis, I will be translating those things. So yeah, we have the severity of the accident. And so you see here, like Canton Zurich has 12 rows because it has severity, the type of road, and whether it occurred within city limits or outside city limits. And so basically, if you sum these rows, then you get the number of accidents per canton. That's what I assumed. That may be incorrect, as it turns out, because the accidents here, so this is accidents with deaths. If we actually sort by canton, we can see that there's actually a lot more than just 12 rows. There's actually 36 rows. And the reason is that the accidents are divided by severity, and there is an accident with lightly injured, heavily injured, and death, or deaths. And what I think, I have not been able to find this out yet. This is something that I've asked the Federal Statistical Office, but seeing as we've been on holiday the past few weeks with Christmas and New Year's, they haven't gotten back to me yet. I believe that if an accident had lightly injured and deaths in it, for example, like a single occurrence, that it's actually classified in both. And that's unfortunate because it means that all the sums that we did are incorrect. So that there were not 17,000 accidents in Switzerland in 2019. I'm not sure if it's correct or not. My gut feeling tells me that 17,000 accidents in a whole year in our country of nearly 9 million, with about 60% of people owning a vehicle or something like that, is actually not so high. So I think it's definitely plausible. If it's correct or not, I can't say. What we're going to do, excuse me 1 second. Sorry, a little cough attack here. What we're going to do for the moment is assume that this number is correct. It's a little bit dangerous, I know, but we are just going to assume that this number is correct for the moment. And the reason we're doing that is because I don't want to re-engineer the entire data set, which I can't do anyway, because I don't have access to the actual raw events, if you will, like of each accident with a timestamp and number of deaths and number of injuries and so forth. So I don't know how to bucket that data differently. So we're just going to assume that this number here that we've worked out based on the sums is basically the number of accidents that occurred in that year. And so actually I have prepared a small table to show the extent of this issue. So we had sorry, just take that away for a second. We had this table here. So the last thing that we finally did was we joined two tables together. So we had road accidents roads and road accidents causes. The roads table tells us what type of road it was where the accident occurred. Especially it tells us under what conditions who had right of way, what was the condition of the road. This is what I'm most interested in right now, and what speed was allowed, for example. And the causes table actually tells us what was the reason of the accident. For example, so it's the suggested accident reason because it's not definitive. And this one, for example, is the condition of the person. So that could be sleepiness, tiredness, alcohol, etc. I don't know how deep this table goes. I think it's 7,000 rows, so there could be quite a few different reasons. Maybe we should just take a look quickly at the reasons. Distinct from FOS causes. It's called mutmaßliche Ursache, which is like suspected reason for the accident. So this is pretty interesting. We have a list here. I'm just going to make this a bit bigger. So they are in German, but I'll just pick a few out. So this one is driving, which basically means driving was the reason. So there's probably no further information. Speed, This is like influence through a third party. This is distraction or inattention, unknown. Condition of the vehicle, for example, right of way, infrastructure, overtaking, or external factor. So for example, a tree falling in the road, for example. I don't know how they would classify it in every case, but it is very interesting to see that there are different reasons here. So okay, that's a little excursion into that. But essentially, these two tables are very different. So the roads is telling us like what accidents happen on what type of roads, under what conditions of roads. And this is an accident table of why do accidents happen. And if we actually look at these two queries, so they're doing the same thing. Select distinct, so just give me only one unique value per row. And then we have the sum of all the accidents of 2019. And we can see that these two tables, so we've joined them together with the road type, because that's the one key that we have available. There is another key available to us between these two, which is, oh, let me just forward the music here. There we go. So we have this Straßenart, which basically means road type. That's one key that we have. We also have this other road type of the location, so inner city, outer city, or city limits, if you will. But the problem is there's only two values there. There's only inner and outer city, so außerorts, innerorts. And that's a real issue because, well, we can't do anything with that information if it's only two. So we do have also the severity of the accident in both of the tables, but the one that gives us the most amount of values to work with is the type of road. So that's why I chose to join those two together. But coming back to the totals, so we see that these actual numbers are different. And that's where I went and just did the sums quickly in a Google Sheet. And so the roads table gives us 17,761. And that number should be familiar because it is the number that we had from our original canton table, which is basically how many accidents were there per year per canton, which we just removed the canton and we had just had the sum of all the year. And the causes table gives us 26,956. So we see that in this table, we are double counting. We're counting more than in the other table. And the reason for that, at least from my perspective in this causes table, is because the suspected reason for the accident, and so if an accident happens, let me approach it a different way. If an accident happens, then we have a reason for the accident. And that accident is one occurrence, and then there's one reason. So that's a one-to-one relationship. However, in an accident, there's more than two parties very often. Not always, but often, which we actually see reflected in these numbers too, in this Google Sheet. So the reason why I think the table of the causes is actually double counting, or triple rather, sometimes, is because each object involved in the accident is also listed within this table. And we see that by here, pedestrian. And actually, there was a death. So let me summarize this row here. There was a accident with, so one accident in 1992 with a death. And it was on a highway, which is outside city limits most of the time. It can be within, but it's very rare. And so there was an accident on the highway involving a pedestrian. And the reason for the accident is the condition of the person. So I would go out on a limb here and say this is probably something to do with alcohol or drugs, right? The influence of the person's condition. But there's probably another accident in this table somewhere where they are also counting, for example, the car. And I don't know if that's the case. This is just an assumption based on the numbers we're seeing in this table that it's being double counted, because each object is being counted. And that's just how I'm interpreting the data. So don't take this as, you know, the answer or the definitive explanation for this data set. It just actually underlines a point that I've made earlier as well in earlier streams. Know the data you're working with. This is publicly available data. So very often there's not a lot of explanation with it because it's just provided as a service to the public. And there isn't a lot of kind of explanations about the data set and metadata and things like that. Very often if you work with data within a company or within a professional context, there will be more information about it there. And it'll be easier to understand because somebody in the company can tell you, oh yeah, this value means X, Y, Z. So I think that's really important, and it's very difficult to work with this data set because we don't know about things like that, about whether they're being double counted. So based on the numbers we saw from these sums, let me just go back here. I'm just assuming that this table of causes is double counting in terms of the sum. So as a learning, we can write this down. As a learning is the road accidents causes table is a n-to-1 relationship with road accidents causes sum of accidents. And this is like a note for me. Okay, now I know that I can't just take the sum of each of these accidents from the causes table. I have to take the sum from the actual roads table, and maybe I can add some additional information from the other table. But that's just, I need to write this down so that we don't forget that. What do we need to do beyond that? We need to look at the fourth table in the data set, which is about the people involved in the accidents. And as I said last stream, I would love to have one data cube that had every accident with a timestamp in it, because this is not time series data. That's maybe, if you're not familiar with data, let me show you a time series data set. Okay, this is a time series data set. So these are all the measurements taken by day for all the different weather stations in Switzerland. And we haven't been working with this data yet, and that's fine. I'm just showing an example here of weather data, of time series data. And the reason it's time series data is because I have basically the primary dimension in this table is a date or time of some sort. I haven't checked whether every day is actually in there, but it goes back to 1864, which is very impressive, actually. And so if I look through this entire data table, then you can see it follows this notation of date, basically. Whereas our table here, it does have a year. So there is a date or time dimension to this table, but the primary dimensions are classifications or dimension information. For example, okay, the result of the accident, what vehicle was used, the type of vehicle or the type of person involved in the accident. So a pedestrian not using any vehicle because they're just themselves. Men between the ages of 0 and 9, so little boys, with no type of what would you translate this as? I would call this some form of protection. So basically it's a 0 to 9-year-old boy walking who was killed. I mean, 4 of them were killed in 1992. And the result of the accident was, death. And now, because we have this table of kind of number of accidents, this is actually, if we look at the other tables, we see that these are basically accidents. But in this table, we could almost say that these are the number of people killed. The problem is, again, that we are not sure about the origin of the data here. So we know that someone can only be classified once by age, and once by gender, and maybe once by how they were participating in the accident. But what happens if they were classified as... Okay, I don't have this on the first page. Let me just keep going here until I find... Yeah, so these are the heavily injured people. So someone who was heavily injured, unknown gender, over 90 years old, without any protection as a pedestrian. What if this person who was heavily injured was also classified later because they died in hospital or something like that? I assume that it wouldn't be double counted in this table. And so one thing I wanted to do was use this table to determine if this is actually the number of deaths or number of injured or heavily injured for these years. Because we have the numbers, if we go back, we have the number of total accidents. So I would like to work out kind of the generics of how many people were involved. And now you might be asking, well, can we join this to our existing set here? What key are we being using? The road type. Do we have the road type in this data set? We don't. We only have information about the people involved. So again, this is like a one-dimensional analysis. And I find that, how should I say? I think it's a bit of a shame, because I would like to have one data cube where I just had all these events in time series data. And if I had basically, if I was going to design this database, it should be like one table, and then I would have to make cubes out of it. But basically it would be something like timestamp, or I don't know, like accident timestamp, right? Something like that. And then I would have like number of vehicle, or I would probably do it differently. I would have multiple rows per table for the same timestamp accident. So I would do accident ID, accident timestamp. Oh, we better be consistent here. Then I would have like vehicle ID, maybe like the license plate, for example. And then like all these bits of information that I would normally use. And then I could say like, okay, there's like some flags like was injured. And I would have all these different dimensions in this table, and I would be able to create the cubes myself. But I realize why they're not providing that. It's because it's probably that data set is massive, and maybe there's even some privacy concerns about, I don't know, maybe there's like a accident location in there, and the location is really specific, and then we could figure out, who caused an accident somewhere theoretically, which should not be public information, right? So I understand the reason for that, but I would want to have like a time series data set. And in future streams, I will work with some time series data. We have this weather data, which we can work with. I have some other time series data, which is a bit more interesting as well, other than accidents. I don't know if accidents are interesting for everyone. It was definitely something I just asked myself, what kind of accidents occur in Switzerland? And that's why we're looking at this data. So the conclusion, TLDR, is basically we cannot join the person's data onto this existing analysis that we started based on these roads and causes. But as I said it last stream, I want to get an idea of how many accidents occur per year. What's the spread like? We looked at this sort of more detailed analysis here, if we run the entire thing that we had last time, where we actually looked at the sort of number of roads in each canton and whether the number of rows in each canton has an influence on the number of accidents. And well, it's not certain, right? There was no sort of correlation or strong correlation. There were in some cases high occurrences of roads had high occurrences of accidents as well, or in proportionally so, but it wasn't always the case. And that's just getting a feel for the data. That's basically just putting it in there and massaging it and feeling it and seeing what's it like. What's this data telling me on a sort of generic level, right? So yeah, we cannot join it to this, but that's okay. This is what we learned, right? This is an end-to-one relationship. And instead of just going further here, I want to continue with this sort of feel of the data sets, right? Like this is like my data set that I'm working with right now. I understand that it's different tables, but so I'm actually just gonna start doing some queries on this person's data set to get a better idea of what's in here so that we can do some sums. And for that, I'm gonna actually split gonna split this into different view. The reason I do that is so I can have a query window open next to the data. So persons, start a new one. It's just so I can see what data's in the table without having to constantly query it. That's the only reason for that. So FOS dot persons. So road accidents persons wrap. I do like to give my tables good aliases. It makes it easier to work with later. And as I said, if you're in the chat and you have questions, feel free to ask anytime. The whole reason I'm doing this on Twitch is to interact in real time. So if you do have questions, then please just reach out and let me know. I don't see anyone right now, but I will continue with my explanations. Because you never know, someone might pop in. So I want to have Unfallfolge. This is the accident result. So I'm just gonna do distinct. So we have, okay, so we have light injured, heavily injured, and death. And because this is a people table, I assume they can only be classified once. So if I were to take accident result and then add the age, for example, age group, then, oops, sorry, then I will only get the maximum number of results, which is basically 1, 2, 3, this is 10 plus unknown for each category, so that's 33 rows, right? So that's pretty interesting. So we already have the potential for 33 different rows based on age. If we add gender, so this is Geschlecht, gender, then we will get another 3, so that's 99, 33 times 9, that's already 99 rows. So we're gonna have to maybe do some separate analysis here of each dimension. Sharpclaw, welcome to the stream. Very nice to have you here. If you have music suggestions, then please let me know. I can't match the Streamlabs DJ feature in your stream, but I can definitely play more or less anything from what I'm using. But yeah, just let me know if you want to listen to something else. At the moment, I have some very classic vocal trance running, so yeah. So if you're just joining, the summary is we are looking at the table about people who were involved in accidents, because we looked at basically the join that we did before of the two tables, and those are just about the accidents themselves. And I'm going to go into more detail about those, but I want to know a little bit more about the people involved in these accidents, because let me just show this Google Sheet again. Basically, I'm assuming that there's like 17,000 accidents in 2019 in Switzerland, and we have actually these numbers for all the years up until 1992. So I have all these numbers of how many accidents there were. And what I'm interested in knowing is how many people were involved in these accidents. Because, you know, could be all cars with people on their own. And so that's what we're doing now, is we're actually looking at this people table just to get a better feel for the data. And so we determined we have 3 possible values for this accident result, which is lightly injured, heavily injured, or dead, unfortunately. And we have the other stuff in this table are pretty interesting as well. There's 2 other dimensions here that I wanted to look at. That is the verwendetes Verkehrsmittel, which translates to vehicle used. Okay. So we have 11 different types of vehicles. Very fast e-bike, a motorized bicycle, which is pretty interesting, motorcycle, bicycle, standard car, slow e-bike, because we actually have 2 classifications for e-bikes. Some kind of transport for things, and there's people transport, others, which includes unknown, and a how would I describe this? Similar to a vehicle, it says. So yeah, kind of like some vehicle. Yeah, unfortunately I don't have any commands. Sharp claw. I haven't really set up my stream for so much interactivity yet, but I will be adding to that. If you have some suggestions for what to add, I have a suggestion box on my profile, and you can put in some suggestions there. I would love to know what you think I should add. The music playlist is one potential option. But I did add the emoji wall, as you can see. So yeah, I need to know more about these vehicle use. So that's the vehicle, and then there's this type of involvement. I don't know if that makes sense in English, but type of involvement. So we have, interesting. Okay, so this means they were in the vehicle but not driving, a pedestrian, so not in a vehicle, or they were driving the vehicle. So if I were to take all the accidents that involved bicycles, just as an example, so the type of involvement, let's keep that in. Let's make a where condition, where verwendetes Verkehrsmittel is Fahrrad, which is bicycle. Filter only bicycles. And I'm writing this out so that people can read it. Otherwise it's in German and no one can read it. And what else do I want? Oh yeah, we had the security system. Like, were they wearing a helmet or not? That could be interesting. Let's leave that out for the moment. So I want to have the type of involvement, and then the Unfallfolge, which is the accident result. And then we can add, I don't know, 2019 in here. Oh man, 2019. So this is accidents 2019. Oh, we need to add a semicolon here. Okay, so we have 70 rows. The reason we have 70 rows is because every single incidence gives us a separate row, and all these other rows, we don't care about them right now. So we're actually going to sum this one. Oh, and these are people involved in 2019. And oh, because we've summed, we also need to use our group by, which if you've already been on this stream before, you know that I forget my group by statements pretty much all the time. We have 2 dimensions, group by 1 and 2. Here we go. Let's do the order by, so it's a bit more tidy. Order by 1, 2. All right, so this is only for bicycle accidents. So type of involvement, pedestrian. There were no deaths, no lightly injured, and no heavily injured in 2019. That means, because no one can be on a bicycle and be a pedestrian. This is why, that's why I said this is so important to actually look at this table, because otherwise you can't possibly understand this data set if you don't look at things like this. So then we have, oh, sorry, I have to take the Google Sheet away here. Or is that only in my view? Oh, sorry, that was only in my view. It's really like necessary to look at the data set, because if you don't understand this, then you can never derive any analysis from it. And so this is important, right? We see that a bicycle can't have pedestrian because you would need to be either driving the bicycle or a passenger on the bicycle. And now you're probably asking yourself, how is someone a passenger on the bicycle? Well, I'll tell you. And I'll tell you, the reason for that is because some people double ride on a bicycle, which are, you know, these accidents here. These 19 people who were injured, they were double riding, or it's actually a 2-person bicycle, which exists too, but it's unlikely. It's definitely less likely, let's put it that way. And so I already know from this simple 8-line analysis, which includes 1 line of comments, from this simple analysis, from this simple query, we already found out one thing, and that is that all type of involvement are listed for all types of vehicles with 0. And basically what this means is that every row exists in the data set, and the ones that don't apply just are zeroed. So there aren't rows missing, which is very good, because if rows were missing, that makes things a lot more difficult. So just gonna drink a little water. Okay, it's important to hydrate. If you're watching, do also remember to keep drinking water, preferably, but you're able to drink whatever you like, of course. I'm just sticking to water now because I'm streaming. So let's get back to this. If we know that each type of involvement will always be listed for every type of accident result and every type of vehicle, then we can actually summarize people involved in accidents based on accident result. And we can do that by leaving the type of involvement in there. So pedestrian, driver, passenger, passenger. So I'm actually going to do, in order to make this a bit easier to understand for the stream, I'm going to do some case when statements to make this easier to understand. So distinct case case when Art der Verkehrsteilnahme equals this, whatever it is, Fußgänger, but it has a weird typo, because that's my bad for importing it that way. Then pedestrian. Then we can add another when in here. Second when. And a third when. No else. So we have Fußgänger. Then we have Lenker /in, which is driver. And you see in German we have female and male, which is why they have this /in on the end for the female denotation. But we don't have that in English, so that makes it a bit easier to write. Mitfahrer /in, which means passenger. So basically, as a pedestrian, or let's write as, because this actually describes that a bit better. So as a driver, as a passenger, type of involvement. Then we're going to have another case when here. Case when Unfallfolge, so this is the accident result, equals blah. Then we're going to call this death. Yeah, there's no other way to write that really. That makes sense. Then we're going to have when Unfallfolge equals leicht verletzte Person, then light injuries, and we have heavy injuries. And just gonna copy this one, I don't feel like typing it. So we've got death, light injuries, heavy injuries, and we're gonna call this one end as accident result. All right. Okay, so if we now regenerate this table, then we see here type of involvement as driver, accident result, and persons 2019. So this gives us an idea of the accidents that happened for bicycles. Now, can we generate this kind of table for each of the vehicles? Yes, we can. Let's have a look at this table again. So we have the verwendetes Verkehrsmittel, which is the type of vehicle used in the accident. So what we can do is we can just take this up here. We're going to call this vehicle type. Oh, we need to expand our group by in here because we have now added another dimension. So now we have this vehicle type in here, and you can see Fahrrad is bicycle. So I'm going to take out this filter. And all of these values now, we have 99 rows. I'm going to actually want to get all these values out quickly so I can use them in the case when without typing them all out manually. Select distinct star from FOS dot persons, and we're going to call this, so now we just take this table. It's a little hack if you want to see this. Once you've copied out these values from the data set, you can copy them, and then in data grip you can do a multi-line edit. So now I have multi-line, so I want to write like this. Oh, to fix the formatting. So what I can do is just hold down Option key, which gives if I drag my mouse up, I can actually select multi-line. And so on Windows, I think that would be Command. So I can just tab in here, and I can write when, and this was verwendetes. The auto completion doesn't work. Yeah, wow, that talking is a bit annoying. 1 second. So the multi-line edit, the auto completion of the fields doesn't work so well, but you can still do basically things like this. Then, so I just did a multi-line edit. We're going to call this fast e-bike. We're going to call this motorized bicycle. None. Pedestrian. We could just call this pedestrian. Then call this slow e-bike. Goods. Okay, transport goods. We should actually do this here for bicycle. We should actually do bicycle underscore motorized, because there's just the standard bicycle, and it enables us to, when we sort this alphabetically, it enables us to see a bit easier. So e-bike fast. So you just use the how do you say, the pronoun in front and then the descriptor afterwards. The descriptor being adjective. Yeah. So Personenwagen is just vehicle. Not sure. I don't know what the translation is for that. Let's check what the translation. Passenger car. Okay. That's fine. Bicycle. You know, I'm doing this for you, Chad. I mean, just so you know, this is really for you. I understand German, but people in chat might not. So, as this is an English stream, so I do want people to understand what we're doing. And so this is transport people, motorbike, my favorite, other or unknown, and this is actually want to put this through the translator. I'm wondering what it says. Vehicle-like device. Okay. That's interesting. Yeah. And what if we don't have a value here? Then we just end as vehicle type. All right. So we've done this beautiful case when for chat. We have the different types of vehicles. We have the type of involvement of the person. Let's say vehicle used. That makes more sense. Type of involvement, accident result, persons 2019. So let's check it out. Bicycle as a driver, 16 deaths in 2019. So this is pretty interesting. I would like to expand this for every year. So we're going to do that thing where we copy paste something we already used. Being this table here. Hey, if I wrote it before, I'm just going to reuse it. Why would I do all the work again? And instead of calling this sum, we're going to call it persons, again with multi-line edit. Persons. Here we go. We have an entire data set. And because I don't know how to visualize this here, other than a table, which is, let's be honest, it's not that readable. We are going to, what should we do? Should we put it into Metabase and play around with it a little bit to have a better idea, or should we just put it in Google Sheets? I think we can just put it into Google Sheets, to be honest. So I'm just going to export this, export to file, result 19, perfect. So if I open up my Google Sheet here, I'll just let you see this as well. So I had some scribbles today. Just gonna resize this bit large, huh? I think that's pretty good. So just gonna go back to normal size. That was zoomed in all the way. Let's import this result 19 it was. Let's replace the current sheet. Here we go. Now we have a beautiful data set. We're just gonna, what are we gonna do here? Split text to column based on semicolon. There we go. So now we have this multi-dimensional table, which is pretty big. Just figure out here. I made this a little bit too big. That should be better now. There we go. That should be good. So we have this multi-dimensional table. And now what we can do is we can plot this. And if, let's just take out, I don't know, the last few years. It's not that interesting. We'll look at the last 5 years as we've been doing before. So we'll just hide these. And if I were to plot this entire thing, let's not forget there's like 99 rows here. Yeah. So there's 99 rows. If we're going to plot this whole thing, Google will tell me what chart type is best, which is this one, which I don't agree with, but you know, that's fine. Obviously, it's too many things for one chart. It's just not really possible to see. We can see there's like huge spike here, spike here, spike here, spike here. Like, we can see that there's certain there's certain types of accidents that occur way more often than others. So we need to either filter by value. Let's get rid of this. We need to filter by value, or we need to filter some other way to see only certain types. And the way that we can do that is actually with a pivot table. So maybe this is not strictly SQL stuff anymore. I'm also teaching Google Sheets stuff. But let's make a pivot table. And a pivot table is nothing else than a kind of, if you will, your raw data is like the cube, and your pivot table is basically a view of that data cube. It's pretty interesting. So what we can do is basically add rows. So we can say vehicle used, and we can add type of involvement, and we can add, I don't know, accident result. We can add everything again. And you see it'll just open them up, and we can take out these show totals so it doesn't crash. But what we should do is start to filter and say, okay, let's see where the type of involvement as a driver. So I only want to see where someone's a driver. And this is kind of interesting, right? So now I don't need to include type of involvement anymore. So I can take it out. So I can see vehicle used and the accident result. Okay, very simple. And now we can add in the column, we can add persons 1992. Oh, this is not, sorry, values we have to use. Let's say persons 2015, which is obviously sum, 16, 17, oh, that was 2008, sorry, 2018, and 2019. So, what is this showing us now? It's showing us the sum of all the people involved where they were a driver. Let's not forget, this is just where they are a driver. These are just drivers, okay? But we can see bicycle deaths as a driver. And now this table is much more visible. And I mean much easier to work with as well. If we insert a chart now, we'll be able to see a lot more. Let's take a look here. So this is really cool. Let's see what kind of chart style we can do. I would say we have a double classification, which makes things a bit tricky. Maybe combo chart is the best. So combo chart, let's customize this. Series, all series, column, left axis. Yeah, we'd have to basically split them off into double column tables. I mean double views, kind of. It's a bit tricky with two-dimensional stuff. Maybe bubble chart could work. Unless it only accepts yeah, it would only accept numerical stuff. So that doesn't work. Let me see. This doesn't work. I was thinking tree map might work, but it does not. So we are going to abandon the idea of visualizing that. We could start grouping them, possibly. So we could look at, for example, all motorized vehicles. So let's add another filter with vehicle used. So we're going to look at no blanks. We'll look at motorized bicycle, e-bikes, motorbikes, other, which we don't know, no pedestrians, and no vehicle-like device. So these are all the normal vehicles, let's say. And if we're just going to look at deaths, let's just look at deaths as well. So accident result, everything except, okay, so just deaths. Now we have like a simple data table. We could visualize this very quickly. And what do we see here? These are just, let's not forget, number of deaths. So one of the things that my parents used to tell me is motorbikes are dangerous. Purely based on this table, I would say that motorbikes are not as dangerous as passenger cars. Why? Because the number of motorbike deaths is decreasing. So you can see here motorbike going from 2015 downwards. It's down to, what was it in 2019? 28. That's just one view of the problem though, right? Because the number of passenger car deaths is higher. However, we know that there are more cars on the road than motorbikes, which skews this number a lot. So we would actually need the total number of vehicle registrations every year, and I was not able to obtain that number. So I'll tell you now that based on this table alone, with raw data sets, it doesn't tell you anything. However, what would be interesting to know is this in relation to the number of accidents that occurred. And we actually have that information. So we could take this information and lay it onto the number of accidents that we recorded for all the years. So I'm just going to go copy those from data grid, but you don't see that. That's fine. So if I go to this Google Sheet, here's the pivot table. So these are the accidents that we had. Let me just split these as well. Semicolon. So these are the accidents we had per year. So what we could do is we could actually divide each of these numbers. So this is like our data table. Because this entire sheet is like a data table, I'm just going to copy it, this data set, just the values. I'm going to copy to this other table here. I just want paste values only. Here we go. So I just wanted those values, right? And what I can now do is put those deaths in relation to the number of accidents that happened. Now let's be careful. Again, the number of accidents that happened is the total number of accidents. That isn't the number of accidents of those vehicles specifically. So we have to be careful when we do this, that we are basically doing a kind of accident rate, irrelevant of vehicle. Just basically based on the entire likelihood of all the accidents that occurred in a year. Of course, each vehicle has a different likelihood, right? So these are the number of accidents that occurred. And what we can do is we can just basically, we can say, so 17736, we could do like, let's call this rate 2015. So we do this. Actually, I'm going to do one thing here. I'm going to make it a bit easier for us to work with this. So I'm going to take these numbers, I'm going to cut them, and I'm going to transpose them. So just so we have those years flowing downwards. And we're going to do like this divided by this. How do I get F4 function? Thought I could lock with F4, but I was not able to do that with my keyboard. So I should be able to drag this down now, because it's locked that. And this is the percent. Now this won't equal 100% because not every accident had a death. But we can see, motorbike, 62, that's 0.35% of all accidents involve the death with the motorbike. So that's, it is dangerous, but let's take a look then, just not only with these raw numbers. What are we expecting to see? We are expecting to see the same, you will actually see the same distribution. And I'll show you what I mean by that, because maybe this is confusing before seeing the actual numbers. Basically, by dividing these against the same number, you're just putting them in relation to each other, but they're not in relation to how many vehicles are actually there. So let me just complete this quickly, and then I'll show you what I mean. In the meantime, if you're in chat, do let me know if you have questions or where you're coming from, where you're based out of. Love to know where you're watching from, whether this is a good time for you. So that's 15, 16, 17. Ooh, I did a little boo-boo here. That's the same number. Yeah, made a mistake. It's actually, I'll move these up then I don't have to adjust them. Oh, it doesn't like that, huh? Okay, then we'll copy. So that's 14, 13, sorry, 14. Yeah, and this one will be this divided by 15. Technically, I only need to lock the vertical with the $sign that's locking the cell, that when you drag it either horizontally or vertically, that it doesn't move, it keeps that cell. But it's just habit to lock both if I'm doing something like this. Here we go. Alright. This auto-suggest feature from Google is also pretty neat. So now we have these rates. We can technically hide these. We don't really need them. And now we can look at this chart. And we had the chart before, okay? You see what I mean? Let's go back to the pivot table. See this chart? See this chart? It's the same. Why is it the same? It's the same because we didn't put it in relation to the number of each vehicle type itself. We had the total number of accidents for those last 5 years. That's these guys here. And those last 5 years accidents are just the number of accidents that occurred in total. So of course, putting this in relation, whether it's absolute, like it was here in terms of absolute deaths, or in relation to the same number in every row, of course it will result in the same visualization. And you know, I'm not being stupid here. I'm showing you this deliberately because I want to show you how important it is to understand the data that you're working with. If you don't have the accident numbers split by vehicle used, then this doesn't make any sense. And so, can we actually get the accident numbers by vehicle used? Well, that's a bit of a tricky question. Let's go back to our data set and maybe we can figure that out. Can we get the accident numbers of vehicle used? Well, we have this road accidents canton, which has what happened in the accident, so deaths, canton, where it was, all that kind of stuff. We don't have anything about vehicles in there. Okay. Do we have causes? Yes, we have a causes table, which tells us the object. Pedestrian, Personentransport, Sachentransport. So it is probably possible to get the actual numbers based out of this table. And I think it would be interesting to try this because going back to our Google Sheet, I think this would be a great chance to figure out the actual rates to see how dangerous it actually is based on the number of vehicles that were involved in accidents. Basically, if I was going to summarize it, let's take just two values, okay? Motorbike, passenger car. Total accidents 2019. Let's assume motorbikes were involved in 1,000 and passenger cars were involved in 5,000. And we had, I don't know, 65 deaths here and 24 deaths here. Then of course, this kind of death rate will be very different for these two, okay? And that's what I'm after. And the only way I can actually get to that is if I know this number here. Not the total accidents of all the accidents that occurred, but the total number of accidents where there was a motorbike involved. So, let's go back to data grip. We can try and get that from this causes table. Now we did a join here earlier, and we saw that making the sum of the causes table based on road type gives us a different number of accidents than we know is our kind of master number. So we have to be very careful about what kind of sums we draw from this table, because we know, okay, this gives us as a total, if I go down here, this gives us these numbers for the last 5 years. 17,736 and 17,761 in 2019. So we have to figure out a way to work with this causes table in a way that gives us the same number of accidents. And that could be quite tricky, and that's what we're going to try and do now. So I'm actually going to get out of this, just this query here, because that's what I'm interested in. I'm going to keep this for afterwards, because this is the number of accidents that we had with different types of vehicles. So we're going to keep that for later. And we're going to make a new table, and we're going to start with this query. And before I get into this, I'm going to do something unusual for the stream. I'm going to take a short break to get something to drink, because I've actually run out of water. And I will be back in just a few minutes. So stay tuned. Thank you very much. All right. So we are back. I am fully hydrated again, and we can continue. So, this query that we are going to do, we are going to see if we can get the number of accidents per vehicle type from this causes table. And the reason we're using the causes table is because we have the object type. The reason we're not using the persons table is because this summarizes the number of people involved in the accident, and I'm not interested in that. I'm interested in basically the occurrences of the accidents. The roads table doesn't have this information for us. So, yeah, we are using the causes table. So let's again split. off to the right. I'm just going to open up the causes table. So we have an overview of this table again. And again, if you have questions or anything, feel free to write in chat anytime. Really, I welcome the interactivity. Don't need to be a silent participant. So, first thing to figure out is how far off are we from this 17,000. Actually, I want to actually copy this number. Did I copy that? I feel like I lost that number. There we go. So, these are the numbers we're after. Based on this road type, these are the numbers we've assumed to be our master numbers, let's say. So, how far off are we? Well, let's take out the road type. Take out our group by. 26,956. What's it double counting? Well, it's double counting in the causes table. It's probably double counting these objects. Will it be possible for us to determine if we can actually get to this number? I don't know. That's what we're going to find out, right? So you're on as much of a journey as I am here. I don't know what the answer is. We're going to find that out, and that's why I'm doing this, to see what the answer is. Ultimately, we will learn from it. So we have. Let's take the master first, which is Unfallschwere, which is Unfallschwere. This is accident severity. And we can keep this group by again. So that's the accident severity. And we can see we have more than 17,000 in that table. That's fine. Let's see what else we can see here. So let's take in the object art. So this is the vehicle used, I think we called it in the other table. Alright, so we have 33 rows. I need to make this a bit smaller so we can see. So we have number of accidents with deaths, number of accidents with lightly injured, and number of accidents with heavily injured. Now, each of these vehicles being used, let's make a filter here. Let's filter, for example, where the object art is Motorrad. So we're just filtering for the motorbike accidents. Now, this is just gut feeling, right? I know how many motorbikes there are roughly in Switzerland. As a motorbiker, I can tell you this is like highly unlikely that there's this many accidents with motorcycles. 3,000 something is very high. So it's definitely double counting. And it's double counting if the vehicle used, let's replace that with mutmaßliche Ursache. So accident, let's say possible cause. So there's a lot of rows here. There's probably only one cause per accident, but the objects used are, yeah, this is the problem. In one accident between a motorcycle and a car, the motorcycle would show up once and the car would show up once. This is the issue with this data set. So I actually don't think it's possible to arrive at the same number. I mean, same number. I don't think it's possible to actually have these numbers from this data set here. So we're probably not able to put those numbers in relation. So what we were trying to do, let me just show the Google Sheet again. What we were trying to do was bring up the rate for each accident, or for, let's say, for deaths, to say, okay, how many motorbikes were there, how many motorbike accidents, let's say, in total, and of those motorbike accidents, how many were deaths, right? But we're not able to do that with this data set, which is unfortunate, but is the reality of working with this data set. Just gonna make a music change, 1 second. All right. Now, if we can't continue with this data table, that's fine. So we can't work out basically the number of accidents involving the number of types of vehicles. We could probably go to the Federal Office of Statistics again and look and see, you know, is there any data that we could use that could give us that data table? But I'm not going to bore you with that right now. Let's continue on our journey of this one here that we had started before. So I did say that I was going to go back to this query and go into a bit more detail about... Basically, we had joined the road types, and I wanted to figure out if we could see whether there were more accidents under certain conditions. And this table here, this roads table, we saw from the counts that this roads table gives us these kind of correct numbers that we saw in the cantons. So I actually want to join the roads table with this causes table. What is this playing? We have to change this. Sorry about this. There we go. A little bit better. And like this roads table has more information about the condition of the roads. But as we just were looking at the causes table, while we can join it, we know that it's going to start double counting stuff. So we can't really join those two tables together. So one of the questions that we were asking ourselves in the beginning was, or at least the question I asked myself, I don't know if you were asking this question, but we were wondering whether we can actually join these two tables together, and the answer is no. I mean, yes, you can join them technically speaking, but it is a n-to-1 relationship. And so we can't use that in the way that I had foreseen that I wanted to use it. So what we're going to do is we're going to get rid of this. It seems quite crude, I know, but we're going to get rid of that. And we are just going to operate with this roads table to answer the question about where do accidents occur. And this is something that has been bugging me since looking at this data set, or since downloading the data set, is where do the accidents actually happen? And so I'm going to keep this common table expression in here because it, you know, doesn't really hurt to have it in there. And basically, this is our raw data set. Let me just get rid of the error. This is our raw data set again. So where do the accidents occur? Well, we have this Straßenzustand, which is the road condition. I wish it would not be in German, but that is the way we got the data. So road conditions, conditions. I would say like weather, for example. And if we make this distinct, we can see that there are 6 types. And again, we could do this case when thing to make it a bit easier for you guys to read. So let's do that. And the way to do that is to copy this over here, to copy these without the header. And then I write here, like that. I use the Option key on Mac, drag down to give me multi-line editing. And I just go when. Again, the auto-completion doesn't work properly. Straßenzustand, so I have to type it out, equals, yeah, those conditions. Then I'm gonna write something, and I've just written, yeah, multi-line. So that's really convenient if you need to do that quickly. And we're gonna end as road conditions. So we're gonna call this other, moist, wet, icy, snowy, dry. These are all the road conditions. And I purposely wrote moist. I know it offends a lot of you, probably, but I purposely did that. Because I think it's funny to use the word moist. Of course it sounds very weird, but hey, that's the way it is. So we have the road conditions, and if we were to just do a sum of 1992 now, we would have the accidents from 1992 based on these conditions. Ah, look at that, we forgot the group by again. Isn't that unusual? And so these are the number of accidents that occur in which conditions. And as we know from our master of 17,761, this definitely looks like that. 17,000. We should do a quick sum here just to do a double check. So this is actually 23,272. So there's definitely, even with this data set, accidents being double counted now for some reason, which is very concerning, to say the least. It's interesting. So we have some interesting problems with this data set. One of the interesting issues we have is that when we talk about double counting, basically we have a data set canton, which is the number of accidents for each of them, each canton. But we were able to kind of get the distinct number in a way, like the number of how many accidents there were, end of story. And we assume that's the number. Like, it's possible that they are being double counted, but it's unlikely because it could only be the case that an accident that had deaths and injuries was being put into both. And that's possible, but yeah, I mean, it's something that I would have to just go back when the Federal Office of Statistics tells me that it isn't, that it is the case that they are double counted, then okay. But for the moment, let's just assume that this number here, this 17,000, is just the number. And if we run this query, we see that we get a higher number, and that means we are having accidents being double counted, even in the roads. Yeah, even in the roads table, which we didn't have, if you remember before. I'm just gonna comment this out. We didn't have that problem based on the road type. What was the name of the Straßenart? Yeah, we didn't have that based on road type. Let me just check this. So I'm going to copy that. I'm just going to put it into a Google Sheet. It's not that interesting for you to see. Oh, that's interesting. The sum is still 23,272. So it does certainly seem like it does seem like we are getting more. That's interesting. I was pretty certain it wasn't double counting before. So this is, again, this is our our master number, if you will. That's the number I think is the correct number. Whether it is or not is beside the point for now. But yeah, I think the roads one is gonna double count the accidents. So instead of taking the raw number, we're gonna have to just divide by the total number of accidents that we have within this roads table. So even if they are being double counted, the relationship between the accidents should be identical. I just need to think about this. So if an accident, so the reason that the accident is possibly being double counted is because of the Unfallschwere, the severity of the accident. That's definitely possible. Yeah. So one of the questions we had asked ourselves earlier at the beginning was, can we find something interesting? And honestly, using this data the way that it is proving to be very difficult. It's not necessarily a skill question. It's really a question of the way that these data cubes are composed, or these views of the data, mean that we can't actually determine kind of incidents, if you will, like sort of if we take the number of accidents, like 17,000 something, for example, for 2019, and we don't have like the raw number for each road type, then it's very difficult to say, oh, well, 17% of accidents occur on this type of road, right? That's just, it's not possible. So if we do have something like this with the conditions, right? The problem is, so let's say this is, I don't know, total 1992. So we have this number now. The issue with that is that the total of this number, 23,272, if we take this number and say, oh, well, oh, I made a mistake here. 2019, I just realized something. So no one in chat pointed this out, but I think 2019, I think we were just looking at the wrong year. Is that really the case? Oh gosh, 17,761. Oh, so this is good. The roads table is not duplicated. That's great news. That's great news. That actually allows me to do what I wanted to do. Okay, so perfect. We're going to take our query from the yearly summary that we did. This is basically all of the aggregates of how many accidents there were, right? So I'll just call this, yeah, let's just call this with yearly summary. So yearly summary, then we have, let's say, road types. Let me just check my stuff here. So yearly summary, these are the total number of accidents. I'm gonna call these accidents like that. Then I'm gonna minify this so we can read it again. We don't need that anymore. Road types. So now we have select case when. Let's just copy this stuff. Again, no point in writing stuff multiple times if you can do it like this. And maybe we're not interested in those other years. Let's just look again at the last 5 years. A lot of things change in 5 years. Laws, etc. So we're just gonna get rid of the other stuff. 2014. If you have questions, feel free to put them in the chat. I'm happy to read and see what you're interested in seeing about this. But what I'm interested in seeing right now is basically if I have the total number of accidents for 2015 and I have the total number of accidents by road type. Oh, that's great. Why is that not working? Straßenzustand. Do I need to group? Yes, I do need to group, of course. If I have the number of accidents by road type, and again, this number here should be 17,761, which we can I can double check again in my just Google Sheet notes here. Yep, which is correct. So I now have all of those things. And the way that we did this in the other table, so we want to bring these two tables together, right? The way that we did that last time, not this table, sorry. The way we did that last time was with a cross join. Because cross join just allows me to basically put the tables together. So cross join, what's this one called? Road types. And this data set looks like this. You see? So I have everything on the same data frame. Wonderful. So, what do I do now? The same thing we did before. Anyone reminded of Pinky and the Brain? Basically, we want to summarize. Yearly summary is YSU, and road types are RTY, for example. And what we want to do is have the incidence of these different road types and how often the accidents occur. And the way that we can do that is again by using our multi-line edit functionality. So we include the rty.roadConditions, and then we do this is RTY. Oh, these are not called, they're called accidents. There we go. 2015. Oh, I forgot about the double quotes here, sorry. Accidents 2015. Float divided by, and these we call, instead of sum, we called them accidents as well. And so this is let's call it incidents. Again, multi-line edit is your friend. Incidents of the years. And we do need to group by one. And that is that. And so basically this table is now the likelihood of an accident occurring under those conditions based on the total number of accidents. So kind of like the spread, if you will. And let's do this again in our beautiful Google Sheet. So I'm just gonna bring that up again for you guys. We're gonna make a new chart here. Split text to column. Oh, split text to column, semicolon. Here we go. So, what do we see here? A lot of percentages, very hard to read with the human eye. We can see some stuff, but let's see if a chart will help us a little bit more. Oh, look at this. Wow. Google has suggested something. Do we like it? Not so much. So I have the different years. That makes more sense. Now, what do we see? The first thing that I see is that most accidents occur in the dry, which is actually not surprising and yet somehow still shocking. So under the best of, let's say, weather conditions, at least in terms of the road is dry and accidents still occurred 3/4 of the time. So basically, in 75% of cases of accidents, the road conditions are not to blame. That's really shocking to me and is a bit worrying because I always worry about poor weather, but actually I shouldn't worry about poor weather based on purely this analysis. I think that's a bit scary, to be honest. That's the first thing. The second thing is, what's the second thing from this table is that the proportion of the other accidents, for example, wet accidents, it moved a lot. And there were definitely years where snow made up a lot more. For example, snow was only 2% in 2015, but 3.3%, almost 3.4% in 2017. And then it went down again. So we could see that maybe some values are floating within a certain range. But the dry one, the dry one, yeah, it's pretty much a big portion of what's happening. And wet accidents, unfortunately, last year seems like it was also very high, at least in terms of the last 5 years. So that's, yeah, that would be my main takeaway from this one, which unfortunately, I don't really like what I found, but that is what the data is telling us. Again, this is based on the fact that we think that there are 17,761 accidents in 2019 and so on, which is fine. I mean, that's an assumption we make of the data set. Going back to DataGrip, we can actually see some other stuff too. So not only the road type, we have other information in here too, in this roads table. So this is just one thing from this table. We could look at something else, like the Vortrittsregelung, which is the right of way. And I think that's quite interesting because this tells us kind of a little bit more about the reason for the accident itself. Doesn't say why the accident occurred. It just said the right of way, at least legally speaking, what was the right of way in that case. So I'm gonna take this case when, I'm not gonna like delete it because we might need it later or something again, but I'm gonna do another one with the values from the what's it called, the column we just looked at. I have terrible short-term memory. Relevante Fortrittsregelung. And again, we can use our little hack to get all those values. So we get select distinct star from SOS, roads, relevante Fortrittsregelung. So we have 11 different interesting, I would say, terms for determining right of way. Again, we copy those out. And then once we have those, we can insert them into this case when. And the way that we do that is by putting them all nicely aligned and then writing our case when. Again, the auto completion is not great. Oh, it does work now. Okay, it wasn't working before. And then we're going to put these in quotes. Then something else. It's having some issues with those. We might actually have to change these to quotes. Oh man, that is very unfortunate because they've used single quotes within their values, so we actually have to strip them out. Oh, this is really messy. I unfortunately am not going to do a case when for you guys. It's going to take too much time. I'm just going to do right of way. I'm just going to tell you what they mean rather than writing them for you. Call this right of way. We can generate this table again. And we can just copy this entire thing out. Oops, last line. And we can again put this in another Google Sheet and a new tab. So paste special, values only, data, split text to column, semicolon. Okay. So again, we have this huge table with these percentages, and this is basically, okay, what are the occurrences of accidents based on this right of way? And I already see something quite funny about this table. But let's see if it's obvious. Again, we're going to switch the row columns so we get the years and we can look at the progression over the years. This value, this orange, is keine, which means none. And so you remember, let me just go back to the previous sheet here. This is the road conditions. And these are the right of way. So we learned something shocking about, I'm just going to forward the music 1 second here. There we go. We learned something shocking about road conditions is that in 75% of accidents, the road conditions are not to blame, which is terrifying if you think about it. Is that even if it's poor weather, in 25% of those accidents only occur in poor road conditions, at least. Maybe the weather itself is not good, but of course we can assume the roads will deteriorate after a few minutes of rain, etc. In right of way, we also see something really, really terrible, which is there is no right of way, which means, so keine Verzweigung, which means 67% around, right? This is just an approximation. Around 67% of accidents occur. Accidents occur where there is no intersection. So this is really terrible, actually, when you think about it. Which I mean, reading stuff about accidents all the time in the news and things like that, it's not that surprising, but it's still really shocking to me. 75% of accidents, the road conditions are not to blame, and in 67% of accidents, there's no intersection. So my conclusion from just those two things should be that accidents should be way more preventable. Because if we look at some other case, for example, where there's a tram, I mean, you read about these terrible tram accidents all the time, but this is nothing compared to the total number of accidents that occurred, 0.4%. And they invest heavily into tram infrastructure and preventing these accidents. But that actually doesn't make, let's say, a lot of sense. I mean, yes, maybe it's also keeping this number down, but basically so many accidents occur where there is no right-of-way change or there's no intersection. So where do they happen? Well, we have to go back to our data set and we have to look at something else in here, which is the erlaubte Höchstgeschwindigkeit, which is the speed that is allowed. And I'm hoping to not see what I think I will see in the table, but let's see about that. Again, I'm just going to comment this out. We might want to have it later. Höchstgeschwindigkeit. Geschwindigkeit. So, permitted speed. Change this to permitted speed. Again, we're going to generate another data table. Order by 1. Does that? Yeah, maybe. I just wanted to sort this one because it's actually speed. Yeah, that makes sense. Sort of. Yeah, we can always sort it out in the Google Sheet. That's no problem. So again, back to our trusty Google Sheet. Let me just bring it up for you again. Permitted speed. What are we going to find here, ladies and gentlemen of Twitch? I hope that more accidents don't occur at high speed, but unfortunately I do think that is what we are going to see. Let's see what we see here. So, hey Sharpclaw, I see you're back for the really interesting part. So, just to sum this up, what I found before. In 75% of accidents in Switzerland, the road conditions are not to blame, which is, for me personally, terrifying. Right of way. 67% of accidents occur where there is no intersection. So they just happen on some roads, right? And what I want to now see is what type of roads do they happen on? Basically speed. Okay, we can see that unbekannt, so unknown speed, is 0. So up to 20. And we can see that these are not sorted properly. So I'm going to drag the 120, I'm going to drag down here. And we can just arrange these. Let's sort these. Oh, no. Data, sort range. There we go. Actually, I'm not so sure we're going to see what I thought we were going to see. Let's see. How many times did I say see? Switch the rows and columns again. Oh boy. Oh boy. What do we see here? half of accidents occur in a speed limit zone of up to 50 kilometers per hour. So around half of accidents. What will I like? Sharp Claw? Sorry, I don't understand what you mean. So the first thing is half the accidents are happening up to 50 kilometers per hour. It's basically like falling asleep, right? But there's also a not insignificant number of accidents happening up to 80 kilometers per hour. It's like 20%. Yeah, it's around 20% of accidents occur in 80 kilometer per hour zones. And I mean, if you're, oh, I see. Songlink. Yeah, they're being auto-modded in chat for some reason. I'll definitely need to change that in the chat settings. Can you whisper me the link? I would love to listen to it. Oh, okay. I can bring it up. Let's see if it finds it. Don't think it found it. Oh, it didn't find that. Yeah, it didn't find that track, unfortunately. Oh, I see. Yeah. Let me get it off YouTube for a second. I have to control the volume, otherwise it's gonna blow your eardrums. Oh yeah, I know this one. Oh yeah. Very nice. This is a great way to end the stream, Katarina. So this is, I mean, if you don't know about Switzerland, about how the, let's say, speed zones are constructed, then this might seem really odd to you. But basically, every city has like zones, which is generally speaking up to 50. So it's not shocking that half the accidents occur in a zone up to 50, because most cities are 50 kilometer per hour zones. Which is, well, yeah, that's just the way it is. But 20% of accidents happening in 80 zones, so 80 kilometers per hour, are basically the zones between cities. And there are a lot of speed changes in Switzerland, meaning that if you drive between two cities, it's quite common to get 50, 60, 70, 80, 60, 70, 80, 60, and so on. To change really often. Like, I mean, every half a kilometer it can change multiple times. So 80 kilometers, when people see this sort of 50 zone ends, which means it's then 80 kilometers per hour, they tend to accelerate really hard and go faster, because the speed will change again very quickly. It's just a behavioral thing. So it doesn't surprise me that 20% of accidents happen in those zones. But yeah, my original assumption of an accident occurring more likely to occur at a higher speed is invalidated by this data set, which does make me happy. But it does make me upset that so many accidents happen under 50 kilometers per hour. Considering that we learned that like almost 70% of accidents occur where there's no intersection, and 75% of accidents, the road conditions are not to blame. It basically means so many accidents are preventable. with very simple measures, and that people are stupid. That's what we've learned. And that's very unfortunate going into 2021, knowing that people are stupid, but I guess we knew that last year too. So if you came here looking for some huge insights, I hope I'm not disappointing you. But yes, the last thing to do in this table was look at the type of road, purely because it's not derived from the city, from the speed itself. So I want to see the road type. And I actually called this road types, but it's not right. I'm gonna call Straßenart. So this is road type. Oh man, I can't type. There we go. Road type. I'm gonna copy this again into our trusty Google Sheet. We're gonna make a new tab. We're gonna call it road type. Paste values. Data, split text to columns, semicolon. These are our road types. Oh, I think something went a bit wonky there. 1 second. Data, split text to column. There we go. I don't know what it did there. Oh. I was too quick with my Control B. It's a great track, Katerina. I like it a lot. I think we could also listen to the other one that I have in mind. But let's finish this quickly. So we'll have to get going soon, because it's a school night, believe it or not. I want to flip this again so we see the time series. Did we expect anything else? Not really. Half of accidents occur on a main road. Now, maybe as an outsider to Switzerland, main road might seem like a weird term. Basically, there's highway next to highway. Autobahn, highway. Let's translate these directly. Next to highway. Autostraße would be a fast road. I don't know what else to call that. And this is a main road. So main road, I mean, the network of Switzerland basically consists of like a huge amount of roads that are small. We do have highways, of course, but I don't know what the relationship is between like the number of main roads to other roads. But I mean, it would be interesting, maybe in the street index data set that we have, we can figure out if roads are different types, but I don't know. Let's take a quick look. I think we have time. We have this street index table, which has all the streets of Switzerland. I don't know if the highways are in here compared to the other streets, but we'd have to work out like the lengths of the roads to determine like the actual relationship of them. So it's probably not something we want to do right now this late into the stream. But yeah, so half of the accidents occur on a main road. I mean, it's a bit weird, but it's actually kind of weird. A lot of these accidents don't actually have a road type behind it. And since your song is over, Sharp Claw, I'm gonna put on the one that I wanted to listen to. And I get ads all the time, of course. So let's see if you like this one. this actually doesn't equal 100%, which is not good, because these columns should always equal 100%. And if we don't have 100% in here, it means, if we go back to data group, it means that we don't have, come on, highlighting issues. It means we don't have the full number of accidents by road type, which is odd actually. If we look at our data set, we have this Straßenart in the whole data set. That's weird. That's definitely a bit weird. Yeah, that's a bit odd. I'm not sure why that is actually. So there should be, basically there should be, oh, I think I missed one in the copy. Ooh, I missed the row in the copy. Yep. I missed one in the copy. Excuse me. I missed this Nebenstraße. So we can add this back in. Yep. That's the reason for that. Oops. Yeah, that makes a lot more sense now. These are... Oh, that's not... Wrong values, of course. I took the wrong values. It is getting late. That's the main reason for me being so incoherent with my numbers here. Data, split text to columns. So these are the actual numbers. There we go. And now these should equal 100%, which they do, and this is side road. So yeah, like I said, this doesn't surprise me in the least, right? That a side road has, you know, half of the accidents occur on a main road and 35% occur on a side road. But it is nice to see that only 10% of accidents occur on the highway. So basically, if you drive only on the highway, your accident risk is the lowest, because yeah, the highway is actually pretty safe. If you're driving at 100 kilometers per hour, or sorry, it's not your speed, but the speed, if you're driving on a highway section that's 100 kilometers per hour, you actually have a pretty low chance of having an accident. If you're driving on a main road or a side road, you actually have a very high chance of having an accident, unless, yeah, I don't know, if you're in a 20, 30, 40 kilometer zone, maybe the risk is a bit less, because the 50 kilometer zone is where the bulk of these accidents are occurring. So that's kind of funny, really. But it shows that a lot of accidents are preventable, which is very sad in a way. So going back to data group, there was one thing I wanted to look at, and that was the split between inner city and outer city. But I don't think it's so beneficial because, well, there's only two values, Unfallort, right? Außerorts, innerorts. And it can be derived from the speed because Außerorts will always be 60 or above, basically above 50. I don't think there's any values for Außerorts underneath 50 kilometers per hour. So if you look here, and we could make a query for it, but the rules dictate that it's not possible. So yeah, summary of today. I think we can use the Google Sheet to summarize what we found. The first thing we looked at was this pivot table about deaths. And like I said, it's impossible to find an incidence rate if you don't have the number of accidents for each vehicle. But purely based on just raw numbers alone, so these were the raw numbers of the total number of accidents, which are not relevant, but purely based on raw numbers, a motorbike and passenger car, for example, you're equally likely to die, but that's, we know in reality, not true, because there are far more passenger cars being driven on the road than a motorbike. So we know that actually riding a motorbike is more dangerous than a passenger car in terms of death, which upsets me as a motorbiker, but doesn't surprise me. If we were to look at accidents where someone's at fault, we would find that 70% of the accidents where motorbikers are involved, we are not at fault as a motorbiker. But that's another discussion. So we'll just call that deaths. We made this other sheet where we wanted to do the incidents, and I explained that we can't do that, so I'll just skip over that. Road conditions. In 75% of accidents, the road conditions are not to blame, which is both very good, which means, okay, even if it's icy or snowy, it's more dangerous, but not improportionately somehow. Oh, we better start some music again. But it's also a bit worrying because it means that you're most likely to have an accident when the roads are in good condition. So it basically means, as a takeaway, if you are driving, at least in Switzerland, I don't know if these things will apply to other countries, but even in great conditions, you should always be alert. That's basically it. In terms of right of way, 2/3 of accidents, or 67% of accidents occur where there's no intersection. So intersections are always a, precarious part of driving, especially as a motorbiker, but also in a car. You're always worried if someone's going to jump the intersection or something like that. But actually, most accidents don't occur at an intersection. So that's very interesting. Also not shocking, to be honest. Half of accidents occur in a 50 km/h zone, which, given the amount of 50 km/h zones we have in Switzerland, is not surprising. But 20% of accidents occur in 80 km/h zones, which means those are like high risk zones. The highway in general is relatively safe, which is good to know. But of course, with increased speed could come increased deaths. That's something we could draw from that table if we wanted to, based on the severity of the accident. We could actually divide these into severity, but we won't do that right now because it's a bit late for me. But it's something we could maybe do in the future if we wanted to come back to this. We could look at the severity of the accident with the permitted speed and figure out if going faster is actually more fatal. So that's something I'm going to write down for next time. Is going faster more fatal? That's something maybe to look at in the future. What else can we look at here? The last thing about the road type. So half of accidents occur on a main road. Yeah, I mean, it's not surprising, but also a lot of accidents occur on side roads. It basically means, 85% of accidents occur off the highway. So only 10% of accidents occur on the highway. It means, again, the highway is relatively safe in terms of number of accidents. Probably not in terms of the severity of the accident, to be honest, but yeah. So that is what we learned today. And I don't have much of an outro prepared or anything like that. Other to say that I will be streaming again, hopefully on the weekend. If you'd like to catch my next stream, I can't divulge too much yet, because I'm still preparing it, but it will most probably be around the topic of movies, around looking at different things about movies. I won't say too much more about that because I think I need to prepare a little bit more before we're ready to actually look at that data. I need to import it still. As you can see, there's nothing imported yet. I've done that on purpose so you don't see what we're going to do next time. That's just tension for the stream. I myself, of course, need to import it at some point and look at the data. So I hope today was interesting. If you have questions, feel free to ask them now. I'll stick around for a few minutes. If you do want to know something or any of the things that we looked at in terms of analysis, I can go back to. Let's say I'm not unexpectedly disappointed in this data set. I realized that joining these kind of cubes together, or these views rather, was going to be basically impossible because of the way that they provide the data. So I didn't expect to be able to join these data sets together. It would have been very cool to be able to do that. Or to even have like basically the data down to postcode level and figure out which postcodes in Switzerland have the most accidents, and then I could, have charted it on put the postcodes with lat-lon data or something like that, and then see here we have east-north. I actually could convert this to lat-lon data, and then we could have mapped it on a map to see where, like, the hotspots of accidents. That would have been very cool. But that's something maybe to do some other time. I mean, we have the weather data as well that we didn't look at yet, but that's very useful to have. I will start building my own sort of repository here of public data sets, trying to describe them on my in my notes, what kind of data I downloaded. As I said, I didn't get a lot of metadata about the road accidents, so some of the stuff here, like the explanations of these values are really difficult. They're not so simple to figure out what this actually means, and I would have maybe been able to get that information from doing some more research, but yeah, I don't think it was super simple to get. So yeah, in that case, I will finish off the stream here if there are no questions. I thank you for paying attention today, asking questions, participating in chat, pasting nice song links, and wish you a good rest of the week, and I shall see you on the next stream, which shall hopefully be over the weekend. Yeah, let's put on a nice track for our for the little sign off here. It's a bit annoying when it has these huge ones, these long tracks. There we go. Are you sad, Sharpclaw, that it's the end of the stream? It has been 2.5 hours and it's a school night for me, so that's the way it goes. Hope to see you next time though, and I'll hope to also catch your stream in the next few days as well, if you go online. Alright, bye everyone, and thank you very much.